Good evening, ma'am. My name is Deborah Nyanapakasam from class DTK2A. My type metric is 15 DTK 20F 2014. Okay, today I'm going to present about my practical work 6, experiment A, experiment B, experiment C, experiment D. So I'm going to start with my experiment A right shift register. So this is my lab sheet. In this lab sheet, they have given figure 1 for the right shift register. Okay, they have said connect the circuit as shown in figure 1 below. So I've constructed the circuit, and this is the circuit for my experiment A right shift register. In this circuit, I have insert 2 dual D flip-flop, 3 slide switch, 1 push button, 4 LED lamp, and then 8 resistor. 4 resistor will be 10 kilo ohm, another 4 will be under the lamp. Under the LED will be 1 kilo ohm. Why we put 1 kilo ohm under the LED lamp? Because we just prevent the LED from exploding. So they have said in the lab sheet, they say set switch 2 and switch 3 1. Okay, I have set it up, switch 2 and switch 3 1, and then switch on the power supply and set the output begin as QA, QB, QC, QD 0. So they have said when we set up the switch 2 and switch 3 into 1, when we start simulation in, the output will become the 4 LED will be not lighten up. So let's see whether it's lighten up or not. So I have set it up. Okay, none of the LED light not lighten up. Alright, okay, next set switch 1 1 and toggle the pulse clock. Alright, I set the switch 1 1 and then I click the clock button. Alright, QA1, QP0, QC0, QD0, and then alright, record the result in table 1 below for clock pulse 0. Alright, I have recorded it, and then for the next step, set switch 1 into 0 and toggle the pulse clock, and then record my result in table 1. Alright, let's see. For the last step, switch 1, and then I go on, press the clock. Alright, now I'm go for my output table. Alright, this is my output table, which is when I press the first clock pulse, the result was QA1, QP0, QC0, QD0. Next, I have pressed the number 2. Alright, the result was QA0, Q1B, QB1, QC0, QD0. Okay, next I go for the third step. Alright, QA0, QP0, QC1, QD1, QD0, sorry. Next I go for the fourth step. QA0, QP0, QC0, QD1. So this is the output for my experiment A, right shift register. Next we go for the experiment B, left shift register. So let's go. Okay, next I'm go for the experiment B, left shift register. So this is the figure for the left shift register. They have said connect the circuit as shown in figure 2 below. So I've constructed the circuit, and this is my circuit for experiment B, left shift register. So in this circuit, I've put 2 dual D flip-flop, 3 slide switch, 1 push button, 4 LED lamp, and then 8 resistor. 4 resistor will be 10 kilo ohm, another 4 will be 1 kilo ohm. Why we put, as specified in the previous video, why we put the 1 kilo ohm under the LED lamp? Because we just prevent the LED from exploding. So this they said set switch 2 and switch 3 into 1. So I've set it up into 1, switch on the power supply and set the output begin as QA, QB, QC, QD will be 0. Alright, when we set it up the switch 2 and switch 3, after this simulation, the output will become QA, QB, QC, QD will be not lighten up. So let's see. Okay, none of the LED light will not lighten up. Okay, next set switch 1 1 and toggle the pulse clock. Record your result in table 2 below for clock pulse 0. Alright, now I set switch 1 1 and then I press the clock. Okay, when we set it up, the switch 1, the output will be QA0, QB0, QC0, QD1. Okay, next set switch 1 to 0 and toggle the pulse clock. Record your result in table 2 below. Alright, now I switch the switch 1 into 0. I off it up, then I toggle the pulse clock. Okay, the output will be, before that I go for my output table first. So this is my output table for the experiment B. So as we said, for the step 2 will be QA0, QB0, QC1, QD0. Next I go for the third step. Alright, okay, the output will be QA0, QB1, QC0, QD0. Next, for the last step, the fourth step will be QA1, QB0, QC0, QD0. So this is the output for my experiment B left shift register. So next we go for the experiment C ring counter. So let's go. Okay, next I go for the experiment C ring counter. So this is the figure for the ring counter. They have said connect the ring counter circuit as shown in figure 3 below. So I've constructed this circuit in the okay. So this is my circuit for experiment C ring counter. In this circuit, I have used 2 dual D flip-flop, 3 side switch, 1 push button, 4 LED lamp, and then 8 resistor. 4 resistor will be 10 kilo ohm, another 4 will be 1 kilo ohm. Under the LED lamp, it's just for the preventing in from LED from exploding. So they have said set switch 1, switch 2, 1, and then switch 3, 0. Okay, switch 1, switch 2, 1, and then switch 3 will be 0. So after you set it up, switch on the power supply and set the output begin as QA will be 1, will be light up, QB, QC, QD will be not light up, which is 0. So let's see, we just press the start simulation first. Okay, as we said in lab sheet, the output will be like this: QA1, QB0, QC0, QD0. So next, set switch 3, 1 and toggle the pulse clock. Record your result in table 3 below. So let's see my result first. So this is my result for the experiment C. Okay, now I will set the switch 3, 1. Okay, now I will toggle it. Okay, so the result will be QA0, QB1, QC0, QD0. Third step, QA0, QB0, QC1, QD0. The fourth step, the third step, QA0, QB0, QC0, QD1. The fourth step, QA1, QB0, QC0, QD0. The fifth step, QA0, QB1, QC0, QD0. The sixth step, QA0, QB0, QC1, QD0. Seventh step, QA0, QB0, QC0, QD1. Eighth step, QA1, QB0, QC0, QD0. And the ninth step, QA0, QB1, QC0, QD0. And the 10th step will be QA0, QB0, QC1, QD0. So this is the output for my experiment C ring counter. Next we go for the last experiment, which is experiment D Johnson counter. So let's go. Alright, next I go for the last experiment, which is experiment D Johnson counter. So this is the figure for the Johnson counter. Okay, they have said connect the Johnson counter circuit as shown in figure 4. Now this is my circuit for experiment D Johnson counter. So they have said set switch 1 to 1, switch 2 to 0. So switch 1 to 1, switch 2 to 0. Alright, so the output will be QA, QB, QC, QD will be 0 and the QD bar will be 1. So let's see. Start smashing it. Okay, that is my output. So which is QA, QB, QC, QD will be 0, QD bar will be 1, and then set switch 2 to 1 and toggle the pulse clock. Alright, so switch 2 to 1, toggle the pulse clock. Okay, now I'll go for the output table before that. Alright, now I will toggle the pulse clock. So the first will be QA1, QB0, QC0, QD0, QD bar will be 1. So the second step will be QA1, QP0, QB1, QC0, QD0, QD bar 1. And then this the step QA1, QB0, QC0, QA1, QB1, QC1, QD0, QD bar 1. The fourth step QA1, QB1, QC1, QD1, QD bar 0. The fifth step QA0, QB1, QC1, QD1, QD bar 0. The sixth step QA0, QB0, QC1, QD1, QD bar 0. Seventh step QA0, QB0, QC0, QD1, QD bar 0. The eighth step QA0, QB0, QC0, QD0, QD bar 1. And then the ninth step QA1, QB0, QC0, QD0, QD bar 1. And then the final step, which is the 10th step, will be QA1, QB1, QC0, QD0, QD bar 1. So this is the output for my experiment D Johnson counter. So that's all from me, ma'am. Thank you so much for listening up my presentation. I'm sorry if there was any mistaken. So that's all from me. Thank you, ma'am.